video, I am going to explain principle of optical fiber. Transmission of signal through optical fiber is based on total internal reflection. For an optical fiber, there are two parts. Inner part is called core, then outer part is called cladding. This is the outer part and this is the inner part. Inner part core has higher refractive index. Then outer part cladding has lower refractive index. Signal in the form of light is made to be incident at the boundary of core and cladding at an angle greater than the critical angle. So the light will undergo total internal reflection. So here light is entering from a medium whose refractive index is higher to a medium whose refractive index is lesser, and when the angle of incidence is greater than the critical angle, it will undergo total internal reflection. So light will emerge the other side without much appreciable loss in the intensity. So that is the principle behind optical fiber. Now let us see angle of acceptance angle in optical fiber. In an optical fiber, there are two parts, inner core, outer cladding. The refractive index of core is N1, clad is N2, then outer refractive index is N3. To ensure critical angle at the core clouding boundary, light should fall at a particular angle. That particular angle is what's known as acceptance angle. If light is falling here at an angle more than critical angle, then only there will be total internal reflection. To ensure that, light should fall at a particular angle. Now let the angle of incidence be IA, then angle of refraction is RA. Then here light is falling at critical angle, so IC, so angle of refraction is 90 degree. Now let us apply Snell's law in the product form at the point A. N3, here refractive is in the N3, angle of incidence is IA, so N3 sin IA is equal to N1 sin RA. Then apply Snell's law in the product form at the point C. So here refractive index is N1 sin IC, this angle is critical angle, so IC is equal to N2 sin 90. Then sin 90 is 1, so we can write N1 sin IC is equal to N2 sin 90 1. So from this we can write sin IC is equal to N2 by N1. Then for this IC, we can substitute from this triangle ABC. In this triangle ABC, this angle is 90 degree. So this IC can be written as 90 minus RA. If when this is 90, some of these should be 90. So IC can be written as 90 minus RA. So for this IC we can write 90 minus RA. Then using trigonometry, we can write like this. Sin 90 minus theta is cos theta. So we can write sin 90 minus RA is cos RA. Cos RA is equal to N2 by N1. Then again we can use trigonometry. In trigonometry, sin square RA plus cos square RA is equal to 1. So we can write like this. Sin square RA will be 1 minus cos square RA. So sin RA will be square root of 1 minus cos square RA. Then for this cos square RA, we can substitute N2 by N1. It's a complete square. It's square. So sin RA is equal to square root of 1 minus, instead of cos square RA, we can square this. So we can write N2 square by N1 square. from this we can write like this. Sin Ra is equal to, take this here, 1 into n square n1 square minus n2 square all divided by n1 square. So we are getting an expression for sin Ra. That sin Ra you can substitute in this expression. So we can substitute for sin Ra from the previous expression. For this sin Ra we can write square root of n1 square minus n2 square divided by n1 square. Now take this n1 square outside, so it will get cancelled. So you can write like this, n3 sin Ia is equal to square root of n1 square minus n2 square. Now take this n3 to the other side, so you will get an expression for sin Ia is equal to square root of n1 square minus n2 square divided by n3. Now if this n3 is taken inside the square root, it will become n3 square. So you can write like this. So sin Ia is square root of n1 square minus n2 square divided by n3 square. Now we can get an expression for Ia and acceptance angle from this. So Ia is equal to sin inverse square root of n1 square minus n2 square divided by n3 square. If the outer medium is air, n3 is 1. So refractive index of air is 1. So for this n3 we can write 1. So angle of acceptance angle is equal to sin inverse square root of n1 square minus n2 square. So this is the acceptance angle. So light can fall at any angle from 0 to Ia, 0 to Ia with the normal at the end of the optical fiber, and it will be forming a cone. Light can form at any angle from 0 to Ia with the normal at the end of the optical fiber, and it will be a cone. That cone is called acceptance cone. Then this n3 sin Ia is known as numerical aperture. So n3 sin Ia is equal to square root of n1 square minus n2 square. When the outer medium is air, refractive index is 1, and so n3 is 1. For in this expression for n3 we can write 1. So numerical aperture will be square root of n1 square minus n2 square. So thank you for watching.